All right, let's begin. So welcome. We have our first unit test tomorrow, and I have one first question and then a few more from the quiz that you got back today. Yep, got it. Third proof on chapter 7 worksheet. Yep. Okay. So geometric mean was the first requested question, and then a couple questions from the quiz, and then the proof. Yes, and I'll kind of break down what to be on the lookout for tomorrow's test. So between two fractions, let's say we have 2 over 5 and let's make this 4 over 3. Okay, so I'll show you the easy way in a little bit, but the official way is you place your number and then on top of x, so that's a ratio, and then equal to x over your number, 3 over 4. Now, if you notice, you're going to cross multiply, you're going to end up with this faster method. So yes, that's the official geometric mean, but the real cut to the chase is this. So we're trying to find out what this is, and this number is you just multiply the two fractions, and then you take the square root. So earlier I showed you it was x over 2/5 equals 3/4 over x, or vice versa. When you do it this way, you'll get x squared equals the product. And then to get rid of this x squared part, you'll square root both sides. So again, to cut to the chase, this is the method to square root both the product. So multiply them and then square root them. So let's multiply those two fractions. You could do this two ways. You can go straight across. So you'll get 6 over 20. Or you can simplify beforehand. So you could either simplify before or after. So if you don't simplify before, you get 6 over 20. And then we can simplify the top by 2 and then simplify the bottom by 2, so we'll end up with 3 over 10. Now that's not our final answer. We do expect more from you guys. So that's one way of finding the answer. The second way is before even multiplying, you can say 2 and 4, since we're multiplying. 2 and 4 can be simplified or reduced. So this is 2, this is 1. Then you multiply across. 1 times 3 is 3. And 5 times 2 is 10. So you can do it either way. So from this point, our final answer is not ready. So we have, once again, we multiplied 2/5 times 3/4, and we ended up getting a reduced fraction of 3 over 10. What you need to do afterwards is you need to separate them. So we're going to put the rad 3 on top, rad 10 on the bottom. And you're like, oh, is that the answer? And the answer is no. I forget if we could, I think so. I think on the test tomorrow, you can make it a decimal. So at this point, what you would type in your calculator, if you want a decimal answer, right, you would go and you would push second button, and then the x squared, so you activate the square root, and then the parenthesis comes out. Then you'll do 3 divided by 10, and then you'll hit enter. So in other words, you're basically taking the square root of 3/10. And so I'm not sure what that decimal answer is. I need a calculator for that. That's a pretty small number. So let's take a look. This is 3 divided by 10. It's 0.3, and you're square rooting it. So that's 0.5477, and it keeps going. So, the more decimals you have, probably the better. And we go from there. So that's the decimal answer if it asks decimal. But if it asks for fraction answer, we're not done. So we have rad 3 over rad 10, and we can never have a rad on the bottom. So in order to do that, this is from Algebra 1, we're going to rationalize the denominator, which means we multiply the top by rad 10 and multiply the bottom by rad 10. That's the one of the ways for us to get rid of the rad 10 on the bottom. So now we're going to multiply the numbers on the top. So that's 3 times 10, 30 on the top. The bottom, well, rad 10 times rad 10 is rad 100. Guess what? That's just 10. So this is the better answer. So earlier we had rad 3 over 10. We converted it to rad 3 over rad 10. And then we converted that to rad 30 over 10. So rad 30 over 10 is one answer, or 0.5477 dot 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 is our other answer. Okay. Factoring, yes. Okay, so factoring. Okay. Oops. There are several questions that involve factoring, so make sure you're pretty comfortable. Samantha, I will go over number 19. Yep, that will be very soon. Yes, there will be a fraction geometric mean on the test, correct? Just like the quiz. So let's see. The next question was number 7, 16, and number 19. So number 7, this one will help Emma as well because she requested for factoring. So perfect. So this was the quiz. Okay, step 1, we cross multiply. So we multiply 2/3 times x minus 6. So 2/3, 2x plus 3 times x minus 6. You multiply the cross product, and then equals to the other cross product. That one is just negative 14x. So now we're going to distribute the two binomials. So this is 2x squared, negative 12x, and then positive 3x, and minus 18, then equals to negative 14x. From here, we need to get rid of the minus 14x. So we're going to move it to the other side. So plus 14x. All right, let's clean up this whole trinomial. It'll end up being a trinomial. So I have 2x squared. Then I have negative 12x, positive 3x, positive 14x. That ends up giving us 15. So plus 3x. 9. Wait. Is that accurate? Hold on. 17. Nope, that's 5. I did my math wrong. 5x. And then minus 18 equals 0. Now we're ready to proceed. Okay, so we cross multiplied, we distributed, aka FOILed, then moved the negative 14x to the other side. So we added it, and so now I got to memorize 2x, 5. Okay. So how do we factor such a thing when it has a number in front? So method 1, I'm going to show you many methods. Method 1 is the eventual goal for everyone, especially if you're thinking of going to Algebra 2 Trig next year. So Algebra 2 Trig, many of the teachers have that high expectation of you being able to factor this pretty quickly. So I'm going to show you the hope, which is the guess and check method. And it's basically backwards FOIL. And I've shown this to my class, but I'm going to show a different technique, but it is slower, but it's still good. Okay, so step 1, if I were to FOIL backwards, right, then that means I need to figure out the first term, what times what will give you 2x squared. Only choice is 2x and x. So I've covered 2x squared. Now, I don't know what the outer and the inner will be yet, but I do know the last term has to multiply to negative 18. So I have many possibilities, right? I could put 6 and 3 here. Oh my gosh, I'm going to put more. This is another possibility, just switching the 6 and 3, right? You could do 9 and 2. Like the list is pretty endless. almost, right? So you're like, oh, dang, there's so much. Well, now what we have to check is the outer and the inner, because I already completed first and I already completed last. So what that means is if I were to actually distribute out the first factors, then I would end up with 2x squared. This outer would be 6x. This inner would be 6x, and the last would be 18. And even if I change one of them negative, these terms will never be 5x. So this is wrong. So then I do it again. So I say, let's try this one. So this is 2x squared, then 12x, then the inner is 3x, and you get the program, right? You're like, oh, darn, this doesn't ever add up, even if you put negative to 5x, so that's no good. So you keep trying and keep trying. So eventually you will get an answer. I'm just looking at this. I think the third one might be the winner because now, let me go to the next page, 2x and 9. Okay, 2x squared, 5x, negative 18 equals 0. But I will show you a more conventional way too. So 2x, oh shoot, I already forgot. Was it 9? Yes, 9 and x and 2. There will be one proof, Emma. So I'm just checking my work. If I do this as my first term, that's 2x squared. This is my last term, 4x. This is my inner, 9x. And my last was 18. Now I just have to figure out which one's negative. Well, I want positive 5x. So if I want positive 5x, that means the 9 should be positive. So I'm going to put a plus sign in front of 9. And I want the 4 to be negative, so the negative 2, it'll be negative 2. So, and then if I were to look back, it will end up being this trinomial. So it's all good. So I completed my factors. I just checked it by doing backwards FOIL. So then now, how do you proceed? Well, we got to solve, right? We got to solve for x. This is number 7 from the quiz. So you put 2x plus 9 equals 0, and you do math from Algebra 1. So you move the 9, and then you divide by 2, and you'll end up with negative 9 halves. And then you do it again for the other factor. That one's faster. You just add the 2, and then you'll get x is 2. So you have two separate answers, negative 9 halves and positive 2. If you want to put it in those squiggles, awesome. If not, just make sure you write down those are your two answers. Now here's the more other way. So 2x squared, you're like, I don't know if I can do guess and check. There's so many different combos and, I have to check FOIL. So the other way is back to what you might have learned in Algebra 1, which is the X box. So to do the X box, you take A, which is the first number, and C, which is the last number, and you multiply them. So that ends up being negative 36. Then you take B, which is the middle number, and now we're trying to figure out what numbers multiply to 36 and add to 5. So the only combination that I can think of is 9 and 4. One of them has to be negative, and it has to be negative 4. So what happens is these convert this 5x. So now this is equivalent to 2x squared, change the 5x to 9x and negative 4x. So that's where these came from. And then keep the last one. So it didn't change anything except the fact that it became 4 terms. From there, we're still trying to factor this. So I did the x. Now I have to do the box. So the box is just an organized way of factor by grouping. You could factor by grouping by doing it this way or putting it in the individual boxes. Same exact thing. This just box is just an organized fashion. So now we're trying to figure out the GCFs, the greatest common factors. So there's something in common between these two items. That's 2x you put on the outside. Something in common between negative 4x and negative 18. I think only negative 2. Is that accurate? I guess so. Because this is weird. Oh, I just realized 2x squared and 9x, they don't have 2 in common. I'm like, this doesn't make sense. Okay, my mistake. Then I look up and down, so these two have a 2x in common, and the last two have a 9 in common. So the outside 2x plus 9 is your factor, and the red outside, x minus 2, is your factor. That's just the same as earlier where I guessed and checked. So guess and check is the eventual goal. If you're still kind of shaky about this, the X box method will always work if it's factorable. Okay, I think 1. All right, so the next question was number 16 and 19. Okay, so this is still the quiz, 16, and this is, let's see, geometric mean. So that one I kind of went over earlier, but it's a good one to talk about. So someone asked earlier, it was between 8/25 and 5/16. So the cut to the chase is you take the product and you square root it. That's cut to the chase. So you can multiply across top and multiply across the bottom. You'll get a humongous numbers on top and bottom, or you can simplify first. So if you are, let's just multiply everything on the top and let's just multiply everything on the bottom, right? That's what you'll get. But a different technique is you can simplify 8 and 16 because it's multiplying, so you can reduce, and 5 and 25, and then you multiply across, you'll get 1/10. Well, guess what? Over here, you'll get 1/10 as well, right? Because 40 and 400 have a common 40. So you'll get the same result. So either reduce first or reduce after. But that's not our final answer. 18 got it. So we have to look at rad 1/10. You have an option of making this a decimal answer. So you plug it in your calculator, and then you could either do square root of 0.1 or square root of 1/10, but you should end up with 0. I forgot the answer, so let me type it in my calculator again. 316 or so, 316-ish. So it keeps going, 2, da, da, da. So that's the decimal answer. Or if you want the fraction answer, a little bit more intensive, but important for next year, you'll split up the top, split up the bottom. Hey, square root of 1 is 1. The bottom is still rad 10. But we can't have a rad on the bottom, so we rationalize the denominator, which means we're multiplying the top and bottom fraction by rad 10. Because if you multiply the top, you'll get rad 10, which is fine, but the bottom, you'll get just 10. So either fraction answer or decimal answer. Most likely you will have to do everything simplest rad form, Brock, yes. And then Matt, decimal or fraction, I think in the directions it does allow you to do decimal or fraction, just like Matt said. So yes, you could do either answer. All right, 18 got added to the list. Let me do 19 first. So 18, okay. 18 is a right triangle, and there are 2 again on the test tomorrow. So here is your picture. We forgot to put in the right angles, by the way, so sorry guys, but I think you guys knew what to do. All right, so from here, different teachers teach it differently. I didn't teach a shortcut, but then my 6th period, they figured out a shortcut, which was really cool. So I could talk about that too. So first, these are 3 similar triangles. If you're having difficulty figuring out the ratios and how are they proportional, my suggestion is put angle marks in your big triangle. So here's 1 angle mark, a 2 angle mark, and then draw the 3 separate pictures. Because if you don't know what side matches with what side, yeah, you're gonna be stuck, right? So this is just a better way to organize everything. So I drew the pictures. I'm gonna just put the angle marks accordingly. how I mark them. And then from there, it might be a little more apparent what everything is. So here's x and 12. Here's x plus 7 and 12. And this is 2x plus 7. So this whole thing is 2x plus 7. Okay, so the last picture is pretty useless because there's only one labeled side. That means we want to use the first and the second picture. And guess what? In each picture, you should have a right angle, which is labeled black, a green angle, which is labeled with a 1 marking. So this second picture needs 1 marking, and every picture needs a red angle, 2 marking. So each picture needs a 1 marking, 2 marking, and a 90 marking. So from there, now I suggested to my students to highlight the sides that are matching. So this side that I'm highlighting yellow is touching the green 1 marking and the 90 degree. So in the second picture, the 12 is matching. So we must make a ratio or scale factor. Well, it's not a scale factor yet because we don't have a number. So it's just considered a ratio. Okay, then we look at the two pictures again, and I'm going to use a different color. Let's use blue. So blue, this is touching the 2 red marking and the 90. So you have to say, is there a side that's touching the 2 and the 90? And there is. So then we put 12 over x plus 7. So I always go left to right, top to bottom, left to right, top to bottom. So here's your situation. We need to solve it, so we need to cross multiply and go from there. So I'm going to cross multiply. So let me hide that part. Okay, if I cross multiply, I'm going to get in one of the diagonals x squared plus 7x, and then the other diagonal is equal to 144. So nice, thank you. Oh, I'm sorry, this is a 12. This is a 12 right here, if you look at your quiz. Okay, so from there, now we are going to move the 144, so subtract it from both sides. We have a trinomial equals 0. And we're trying to figure out what numbers multiply to negative 144 and adds to 7. So I'm doing guess and check method, okay? You could do Xbox if you are familiar or like that too. So same situation, just organized. I want to say it's 24. No, let me see. Not 12 and 12. I don't know the numbers off the top of my head. Let me use my calculator really quick. So 144 and 24 and 6, 16 and 9. Thank you. There it is. So 16 and 9 work. They both, one of them has to be negative. Looks like the 9 has to be negative. And then from there, our two answers are x equals negative 16 and x equals 9. These are your two answers. But your final answer is only 9 because if you look back at your picture, if you plug it back in, you can't have a negative 16 for a side length. Therefore, at least for tier 2, I would like my students to write both answers like so and then cross out the wrong answer. It doesn't work due to the fact that there's a picture attached to it. If there was no picture, both answers are good. Okay? All right, so next one is number 18 on the quiz. And then we'll talk about the proof and 18, assume the angles. Oh, we just did 18, huh? I'm sorry. 19. Oh, I went out of order. I'm so sorry. Okay, so 19. So 19 was this picture. 6x, x minus 1, 2x plus 4. This was a common mistake This is incorrect. This was incorrect. And specifically, this bottom was incorrect. So unfortunately, this is not side splitter, because side splitter would have literally been the sides. So we can't do it that way. In this one, we have to look at the small picture, and we have to look at the big picture. And the big picture, this side is x plus 6. So if you put x on the bottom, that's where the problems happen. It wasn't your algebra, it was your setup. So the bottom is x plus 6. From here, we're going to cross multiply and we're going to solve. So again, once again, you have to look at the small picture compared to the big picture. So 6 over x plus 6 and x minus 1 over 2x plus 4. Okay, all right, so then I'm going to go to the next page. 6, x plus 6, x minus 1, 2x plus 4. All right, let's cross multiply. If you multiply these two, so you have these two factors, we're going to distribute it. So x squared minus 1x plus 6x minus 6. And then the other diagonal, you have 6 times the quantity of 2x plus 4. So that's 12x plus 24. All right, whenever you have an x squared situation, you want to move everything to the x squared side. So get it equal to 0. All right, so I have x squared. These are 5x minus 12x is negative 7x minus 6 equals 0. So that's your trinomial you have to factor. Okay, x squared minus 7x minus 6. Still not done. And if you like the x box, you would multiply AC, so that's negative 6, and B, which is negative 7. The two numbers that multiply to negative 6 are 6 and 1. And wait a minute, they don't multiply. They don't add to negative 7, though. Did I just copy something wrong? Negative 6. Oh my gosh. Oh my gosh. Okay, this is supposed to be minus 24. So this is minus 30. Oh my gosh. Okay, let me change this. Minus 30. I was like, this is not working. Redo. Minus 30. So the two numbers that multiply to negative 30 is negative 10 and 3. My apologies. Negative 10 and 3. So your factors are x minus 10 and x plus 3. You don't have to do the box here because the number in front of x squared is 1. Okay, but if you had a number in front of x squared, you will need to do the box method. All right, two answers. We got 10 and negative 3. But remember how there was a picture? Here's the picture. So what's one answer that doesn't work? That one answer that doesn't work, if you plug it back in, it won't be good. So my students, please write both answers, but cross out the one that doesn't work according to the picture. Okay? So again, a lot of factoring, probably 3 or 4 questions dealing with factoring. Okay, so you set it up and then factor. All right, so those were the questions from the quiz 7, 16, 18, and 19. Then let me talk about the proof worksheet, and then I'll talk about just a quick run through of what to expect for tomorrow's test. So let me just talk about the proof. Just in any general proof, if you're trying to prove that two triangles are similar, what you need to show is first, depending on your picture, right? They're similar by angle, or side angle side, or side side. So let's say we're trying to prove two triangles similar by angle. So I'll draw a picture. Let's do, I should do the proof that one person requested, but just giving a little practice. So let's say here's one. 2, 3, 4. We could do even the middles too. Side splitter would only work on 19 on the partner quiz. Yes, that's correct, Miko. It has to be on the sides, the outsides, not on the parallel sides. Okay, so A, B, C, D. I'm just kind of making one up that's kind of similar to the test tomorrow. Okay. Let's say the given is AB is parallel to ED. It's given. And we want to prove in the very end that AB over DE is proportional to AC over DC. Okay, that's the goal. That's the proof. So right before that, we want to show that triangle ABC is similar to triangle DEC. And according to my picture, I'm not going to even do the proof, like the formality of it. I know if the lines are parallel, then angle 1 and 3 are congruent, and angle 2 and 4 are congruent. Does anyone know why they're congruent? Not just from thin air. How are they congruent? Why is 1 and 3 congruent? Perfect. Okay, so if you look at the picture, how are the two triangles similar? They're similar not by side angle side, because there's no sides, right? It's got to be angle angle. Yes. So at least we know how they're similar, okay? So now, right before, we have to state the angles are congruent. So we're going to say 1 and 3 are congruent, and 2 and 4 are congruent. Sorry, this is the angle symbol. And that's because of alternate interior angles. So like number 1, number 2, here's number 3. So you're like, well, what's step 4? Yeah, we could use VAT as well. We could throw that in. We can say, angle 5 and angle 6 are congruent by VAT. We could say that. But we already have 2 angles, so that's why I didn't really write that down. But awesome. So they are congruent by angle similarity. So number 4, the reason why we can say AB and DE are now proportional to AC and DC is because sides is kind of like CPCTC. I don't know if your teacher used that, but for me, I'm going to just say sides are proportional in similar triangles. Did any teacher, McKee, Haygood, or Bratcher use like a CPCTC for this one, but maybe change the letters? Anyone do that? It'll be probably like corresponding parts of similar, oh my God. No? Okay, corresponding parts of similar triangles are proportional. I don't think so. Okay, so we don't have to worry about that. So something along the lines that, hey, the triangles are similar, so now the sides are proportional. Something along those lines should be your answer, okay? If we're trying to use side angle side, make sure that, the sides are actually proportional. Similar problems to 1819? Yeah, I could do that. Let me go back to the proof. I gotta find it. I forgot who asked for the proof, the third proof on the proof worksheet. I don't think it's gonna be as hard as that. So, but that one you do need to use a lot of, what do you call it? Corresponding angles. So this was a proof worksheet. This is the third one, and I won't do it so formally just because it won't be so super important, but it is a good question. I totally drew this wrong, but we'll make do. So in the given, it said that we have a bunch of midpoints. So in other words, these are all mid segments inside. So step 2, I'm just going to say it verbally. Step 2, you want to say that TU and UV and TV are mid-segment. So they're parallel to the third side, okay? So if they're parallel to the third side, then we have a lot of corresponding angles, a lot of alternate interior angles, and all of that stuff. So let's start drawing in here. Oops, wrong color. So let's see, I have 2 lines that are parallel. So these are parallel. And then I have cut by a transversal. So here is my transversal. So I can say this angle down here corresponds to this angle. Oops. So those are congruent. Okay, the blue dots are congruent. And then, let me see, those are parallel. And then I have this as my transversal. So I can say these 2 angles are congruent as well. Sorry, it's getting very messy. So the big goal here was you want to show that the triangles are similar. QRS, that's the big one, is similar to TUV or VUT. And the answer, the goal was angle, angle in that part. So I so far only have 1 angle here and 1 angle here. So that's only 1 pair of angles. I need to find more transversals and more alternate interior angles, corresponding angles. So if these 2, oh my gosh, this is terribly drawn. I'm so sorry. If these 2 are parallel, then we got to find the corresponding angles, the alternate interior angles. So I can mark this angle in here and this angle in here. That doesn't help too much. Let's see, this could be the transversal. So let's see, this is the transversal. Here and here is the same thing. I already did that. Corresponding angles would be here and here. Let's see. I need to find the third angle or second angle. But let me see. In other words, it's getting super messy. I'm sorry, guys. We want to show that a bunch of angles are congruent, and the goal was we want to show we got angle, angle, let's say, and we got angle, angle. So that's the main goal. I'll do number 2, and I'll do 18 and 19. I'll make up something similar. Hopefully I could find numbers that'll work out well. All right, this is number 2 from the proof worksheet, and it was similar, but it was a lot easier. So 2, similar picture. Here, here, here. So we want to show that this inner triangle is similar to the outer triangle. And they did say that these bisected, so basically mid-segments again. So here we could use the fact that this number, I'm just going to put number 1, and this number could be 2, right? It's double. So we are going to basically write a bunch of proportion, like we're going to write a bunch of ratios that are proportional. So I have to put letters. I just made up 2 and 1. Those were not given. I just did it for making sense out of it. So I know the fact that BC compared to JK, that's going to be a 1:2 ratio. Just because I know this has 2 tick marks and this one has 2 tick marks, but there's 2 of them, so it's double. I also know that AC and JL, that's a 1:2 ratio. And lastly, I know AB and KL have a 1:2 ratio. So the inner mid-segment and the outer third side, they have a 1:2 ratio. So you want to show all three of them are proportional because they are, right? They're all equal to 1/2. So then that would be sides are proportional. So these two triangles, I know I didn't mark it well, but these two triangles are similar because of side, side, side. So then we finally say, boom, the triangles are similar by side, 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 because we showed that the sides are actually proportional. So they all have a 2:1 or 1:2 ratio. Okay, let me preface. I know in my classes I kind of mentioned some prior knowledge. So if you see something like this, and it said A, B, C, D, this is not labeled for you yet. But what if I said ABCD is a trapezoid? That's given. Someone could type in, what could step 2 be? What can you infer if you know it is a trapezoid? Like how would you know it's trapezoid? Something's labeled. Parallel. Yes, parallel sides. Exactly. That's definition of trapezoid. So we can say BC and AD are parallel. Perfect. And you write definition of vocab. I don't know if it's isosceles because I never mentioned it. I know it looks like it. Sorry, Matt. But we don't know for sure. I never said it was isosceles. Okay, so let me throw in something else. So let's say I throw in here. So I can't give it completely away. I'm just trying to have you guys think it through. So let's put a 1, a 2, a 3, a 4. Now that you know the opposite side are parallel, what can you conclude from the picture? Go ahead and start typing. What can you conclude from the picture? I could do 11. Yes, alternate interior angles. So we can say angle 2 and angle 4 are congruent. Yeah, so that might help you tomorrow, okay? So this doesn't help us in total, but I'm just trying to brainstorm for tomorrow. Another picture. What if I had, a triangle, and then I had, this is parallel, so A, B, C, D, E. And I'm trying to prove in the end, AEC is similar to BED. So we know AC and BD are parallel. That's given. And then what can you say more about the picture? Put numbers just to give you some hints. So what can you say more about the picture? Some old prior knowledge. Okay, some people were typing, but they stopped. Okay, so we got angle 2 and angle 3 are congruent. Got corresponding angles, correct? Are congruent. Also, there's another set, 4 and 5. So angle 4 and 5. So although I could say angle 1 is congruent to angle 1, I don't need it, right? Because I have already angle. So my final answer, they are similar because of angle. Now, if someone remembers from earlier, I typed this, I wrote it down. Someone could type it. What if my fourth goal is saying AE over BE is proportional to AC over BD? What would the reason be for number 4? So in this case, it's like a sentence. What would the sentence be? Yes. Yep. So similar parts of similar triangles are proportional. Tiers class could be sides are proportional in similar triangles. It all comes down to saying sides are proportional. Yep. Okay. All right. So that's kind of prefacing for your proofs tomorrow. Just make sure you use the definitions, you use the givens, you use alternate interior angles, corresponding angles, etc. And then angle, side, or side. Okay, let me make up or do 11 from the quiz, and I'll make up some new ones of 18 and 19 and go from there. So 11, it said there's a 5'6" person, and then standing near a 120-foot building, and casts a 22-foot shadow. So the question is for the person, how much, how many feet is, or how long is the building's shadow? So what's the building's shadow? Okay, so first, this one is kind of bad right here because it's in two separate units. So you could just convert this entire thing to 5.5 feet because 6 inches is half a foot. So you could do 5.5 feet. Or you have options to convert everything into inches. So I already saw a lot of feet, so I just changed this to 5.5 feet. If it's 5 feet and 9 inches, that will be 5.75. If it's 5 feet and 3 inches, that will be 5.25. Or just convert everything to inches, and you could reconvert back to feet after. Okay, so 5.5, 120, and then 22. So here's kind of a picture. Here's the stick figure man. He's 5.5 this way. And then the shadow is 22. Then the building, taller building, that one is 120 feet. And it's wondering what the shadow is, which will be x. So we want to match, we want to make ratios that are the same. So 5.5 and 120 are the heights. So that's your one ratio. And then your second ratio would be the shadows. 22 over x. Now, you could do it a totally different way. So this is the most common way, but some people are pretty creative and it's still correct. So you could also do 5.5 over 22 equals 120 over x, because look at your cross products. It's still the same. So they're both okay. But we're going to solve 5.5x equals whatever 22 times 120 is. That is 2,640. And I'm going to divide by 5.5. And I get 2640, 5.5, 480 feet. So that's reasonable, right? The building is taller, so the shadow is going to be way longer. 480 feet is a very large shadow too, but maybe the sun is very low, so then the shadow stretching out very, very long. Okay, that's number 11 from the quiz. Then we'll do 18 and 19, similar question, just change numbers. Any more factoring? You guys okay with factoring? Okay, let's see. All right, so similar to 18. Okay, so I'll put here, triangle, make this inside, 9 and 10, sure. So let's see, make the inside 14x. I have no idea if this will work, so let's just hope that the numbers plan out. So hopefully, okay. So step 1, we need to figure out what matches with what. So again, highly recommended, mark your angle and mark your angle. So 1 and 2, When you redraw your picture, mark them accordingly. So here's x, here's 14, and then here's 14 and x plus 6. Once again, I don't know if the numbers are going to come out right. Here's the 1 marking and the 2 marking. So you always need a 1, a 2, and a 3 marking. So this bottom corner needs a 1 marking, and then this other bottom corner needs a 2 marking. Okay, let's match the stuff that's proportional. So this side is corresponding to this side. The reason why it's touching the 90 and the 1, touching the 90 and the 1. So here we go. We got 1 ratio. Then let's take the 2 marking in the 90 and the 2 marking in the 90, and that's another ratio. So once again, I don't know if the numbers are going to work out well. I just made it on the fly. So I get x squared plus 6x equals to, I really doubt this is going to work, 196. When you subtract 196, you get this. And then you'll have to factor. But since I made this on the fly, I don't think it'll work. 196. 196 divided by 4. Yeah, I don't think it'll work. I don't know. I don't know some factors. We gotta keep testing it out. 28 and 7. So products of 196 are 28 and 7, 14 and 14. Doesn't look good. So sorry, I couldn't make one up that well, but that's the goal. You want to make sure you set it up correctly. And then you cross multiply, you do your algebra. And I'm sorry, this one we couldn't factor. On the test, we were more thoughtful, so we made sure that they are factorable. But this one, I don't, at the top of my head, I can't think of numbers that multiply to 196 and adds to 6. Yeah. Okay, so I'm going to make another one similar to 19. So once again, I'm not sure if the numbers are going to work out. So let's make this 8 and x minus 3 and 2x plus 6. Again, I have no clue if this is going to work. I don't like 6, maybe 7, but it doesn't matter. Okay, so the setup is really important. So step 1, we cannot do side splitter, cannot. So please use the small picture and the big picture. Okay, so let's not do the algebra, but let's just make sure we know how to set it up. So the setup will be 8 over x plus 8. And then x minus 3 over 2x plus 7. So once we set it up, then we cross multiply. Whoa. Then we cross multiply, and then we'll do the algebra. But once again, I'm not going to spend the time doing the algebra just because I feel like the numbers are not going to come out. Okay, number 10 and 9 and 10 on the quiz. And then we have a few more minutes. I'm going to just make sure before we leave, I'll do a quick run through of what your test would look like. It's going to look just like the quiz, but just a couple different numbers, different pictures, different figures, etc., different polygons. Okay, so number 9, that one is this figure. 10, 5, 6, x, y, 24. This is not a side splitter theorem either. So unfortunately, you cannot do, side over side. So you got to do the small picture, which is 10, 5x, and the big picture, which is 16, y plus 5, and then 24. So currently, I can figure out the scale factor because I have a 10 that matches with 16. So currently, scale factor of the small picture to the big is 10 to 16, which I'll reduce to 5 over 8. So it's 5 to 8 right now. Now to find the other side lengths, what I would do is I would use that scale factor. I would use the reduced scale factor, highly suggest, and then make another ratio. So x and 24 look like they're matching partners. And then I would cross multiply, and x would be 15. Okay, then to find y, I would do it all over again. I would do 5 over 8, the scale factor, equals to 5 over y plus 5. Now, I have a trick for this. Look at the top. The top answers are the same. So that means the bottom answers have to be the same. And that requires y to be 3, because 3 plus 5 will be 8. But you could always cross multiply and you'll get the same answer. Okay, just like this one up here, 5 over 8, x over 24. Look how you're multiplying by 3. So the top will multiply by 3. That's how I did it really fast. I didn't even cross multiply. Okay, all right. And then number 10 on the quiz is, oh, I think we already did that. So 9 and 10 were both from this picture. So number 9 was x, which was 15. And then number 10 was y, which was 3. Okay, let's do a quick run through of what is expected. So let's see. Okay, make sure tomorrow, I know I did this for my class, I'm going to change up the numbers. Perimeter of rectangle is 200 centimeters. The width to length ratio, if you're in my class, Tears class, and if you get this wrong again, practice. Okay, so the width to length ratio is 3 to 7. Okay, so the question is find the width. Okay, so think about this, right? We're trying to figure out the width of this rectangle, and the width to length is the 3 to 7 ratio. If you have paper in front of you, I would try to do this as a practice problem at home. And the answer is not 60. The answer is not 60 centimeters. Okay. So think if you got 60, like darn, you need to remember that a rectangle has 4 sides. 4 sides. Perimeter has adding 4 sides. So we're not dividing by 10. Not dividing by 10. We're dividing by 20. So you have to interpret this as 3 to 7, 3 to 7 as an extended ratio. So that means all of this, that's 20x, is equal to 200, where x is 10. Then the width is 3x, so you're going to say the width is 30 centimeters. And then just think about it. Use, your numbers. Do 30 plus 30 plus 70 plus 70. Doesn't that add up to 200? Right? And the width to length ratio is 30 to 70, which is 3 to 7. Make sure you think it through, okay? That one is on the test tomorrow. Then there's, let's say a over 5 equals 7 over 8, and I want to get 13 over 8. So you sometimes need to change the original proportion. meaning you could rearrange it so that it's beneficial for your situation. So I could change this and I could make this a over 7 equals 5 over 8 instead, because using the original one will not get me 13 over 8. So now I'm going to use, oh my gosh, sorry. I'm going to use this proportion to help me get 13 over 8. So now if I look at 5 over 8, I'm like, how did I get from 5 over 8 to 13 over 8? I added 8 over 8 on the right-hand side. And then on the left-hand side, that means I have to add 1 because this fraction is just 1. But I can't add 8 over 8 because that's going to be problematic. So instead, I'm going to add 7 over 7 because then common denominators happen. So that means my final answer will be a plus 7 over 7. Let's see, how do you know it's not going to get you the proportion? Well, you can try, because if you use the original black proportion, the original that you gave, and if I add 1, right, that's 8 over 8, that'll give me 15 over 8. I don't want 15, I want 13. So I know that I had to rearrange it. But if I did give you 15 over 8, it would have been much clearer, okay? So there's some tricky ones you have to think about. What would this answer be using the original or the red one? Okay, if I did 7 over a, what would your fraction be? So that one is not as hard. Nothing is crazy. What fraction would 7 over a be if we used the red or the black proportion? And that would be 8 over 5. Final answer. So I just changed, I looked at this one and I turned it upside down, so I have to turn this one upside down. So make sure you're able to kind of change them up, and then when you do change them up, your cross products are always the same, so that doesn't change. There will be, make sure you know how to find angle, the sum of interior angles of any polygon. So that formula might be given to you, right? This one formula. So if you have 4 sides, you plug in 4. If you have 6 sides, hexagon, plug in 6. Let's see, number 21. Yes, 21. Oh yeah, that one is, there's a shortcut because there's no triangles in the picture. 1, 2, 3. Because of the parallel, we could do the side splitter theorem. It's like a corollary to it. So we just take this side right here and do 18 over 9 equals the other side, which is 24 minus x over x. So you could feel free to reduce 18 over 9. So that'll be 2 over 1, just because the numbers will be smaller. And then equals to 24 minus x over x. Cross multiply, so 2x equals 24 minus x. Add x to both sides, so you get 3x equals 24, and x equals 8. If you have time tomorrow, plug it back in. So that means this is 16, this is 8. Guess what? That's a 2 to 1 ratio, so that works out. So you could use side splitter theorem tomorrow. There's another question like 20, but harder tomorrow. So let's say you have an angle bisector. You have 24, 12, and let's say you were given x, and this whole thing is 30. So whenever you have an angle bisector, you need the parts. You need these parts, and then you need these parts. So first setup will be 12 over 24 equals x over blank. You're like, oh no, I need to figure out this length. Well, you can. The total is 30, and then the leftover is x. And then from there, you can reduce 12 over 24. Feel free to reduce it so your numbers get smaller. You don't have to reduce later. cross multiply, and you'll get your answer. So your answer will be, looks like 10. Ah, add x. Yep, your answer looks like 10. And then double check your answers if you have time, right? So plug it back in. So this is 10, and this side will be 20. They add to 30. So look how 10 and 20, they give you a 1:2 ratio. So that worked out too. So again, just make sure you use your facts and you set up all your proportions correctly. Yeah. All right. Any other last questions? So again, know how to factor. As your little exit ticket, as I'm getting the link, I'll give you one more to factor. So don't write the answers down. I'll give you guys 2 minutes. Let me put my timer on. Just for practice, okay, a factoring one. Again, don't give it away. If you finish early, just hang tight. Oops, I already started the time. And let me type it in for you guys. Let's see. Ooh, this one is interesting. Okay, so I'm going to type it just for practice. All right. So I have 3x squared minus 16x minus 5 equals x plus 1. So set it to 0 first, and then try to factor. So I will give you 2 minutes. In the meantime, I'm going to put the link up in the chat box. Okay, so 2 minutes. Don't put the answer yet. I'll let you know when time's up. Ready, go.